Hello, good morning. This is Professor Khan, and this week is week 7 material. Actually, it's week 8. 7 was the midterm, and this week we're covering chapter 5. So by now we have covered basic electricity, basic electrical circuit, resistances in parallel and series, and now we're moving on to components. So for us to use an electrical circuit, we need to have three things, as we said before: source, path, and loads, and this would compose all the equipment we have and all the appliances or things that do work for us. And as you work on the project, probably you'll be able to recognize these components as you go along. So this is chapter 5: components, symbols, and circuitry of air conditioning, wiring diagrams, or also we'll go into furnaces, but this is the simple ones. Okay, moving on. So after completing this chapter, you should be able to explain what electrical loads are and their general purpose. What do they do? How do they work? What do they look like? And how they are used in the industry. Give examples of common loads used in HVAC. Identify the symbols of common loads. What do they look like? For example, resistance look like that. Capacitor will look something like that. So it's good to know these things. And again, they differ sometimes from one industry to another. Explain the symbols and purpose of relays and contactors. We will use these a lot. Relays and contactors are communication between two circuits. So some circuit will control another sub-circuit using a relay or contactors. For example, for the AC, you turn on your thermostat. The thermostat is low voltage, and it will connect with the AC and turn on the high voltage, which is the compressor. Switches that turn things on and off, and some other controls like diodes, delay function, timers, and all this kind of little things that used to be mechanical and now they are electronic. So it's good to understand how they function, what they're made of, and all those other components. Okay. Also, we'll talk about wiring diagrams. What are the types of wiring diagrams? There are some wiring diagrams that are very involved and they have too much information. Those are called the factual diagrams. They have every little things on the diagram. And again, you can always request to look for another simpler diagram. There's an installation diagram. The installation diagram basically just tells you where it goes in and out of the control, and the factual diagram has all the components and the wires inside of the control or the equipment. So loads, electrical devices that consumes electricity to do useful work. Example: motors, solenoids, resistances, heaters, and other things that consume current. And again, we go to the loads here: currents and resistance. You're supplying the voltage, and the resistance is constant in a way, and the amperage is what you are using at this voltage. So this is what you end up using power from, using the power law. If you go to the power law here, the power using current and voltage is constant, and the power is how much current you consume. Again, I go back to the water example. The water company will bill you based on how much water you consume, not the pressure, right? So the pressure is your voltage, so they supply with pressure, and you know your consumption, which is your faucet, your washer, and the current is the flow, how much consumption you're getting. So most important things of any HVAC equipment or any electrical equipment is the loads, because this is what you were doing work with. They perform all the work with it, be it resistance or capacitors or what have you. So these things do control and use work. So these are some examples. Here are some examples of these loads. So here we see a motor. Sorry. So this is a motor. A motor is one of the one of the most common components we have in our industry. A motor turns on a pump. Here's a motor. A motor also turns on a compressor, and that is always going to be something we'll use. A motor also turns on a fan. So a motor is a big component. It's very common and consumes most of the loads. If you actually go to the bottom of it, everything in any kind of appliances that we run through is either a motor or a heater. If you look at a hairdryer, it has a motor and a heater. If you look at a A coffee maker has a heater, so there's always some kind of a motor and a heater as we go along. Here is a coil, and a coil uses magnetism to push a pin up and down. And here we have a heater that is actually used for heating air. This can be used in along with duct to heat the air coming through. This is a pump here. This is the pump part of this pump assembly, and this is the motor. So motor gets replaced, and they do most of the work. And in this compressor, there's also a motor that is connected to an air pump, which is basically a compressor. So it's good to know these things. And we will do 2 weeks talking about motors. What is a motor composed of? How do we rate a motor? How do we replace it? Because again, motors do most of the work in these in our applications. So motors, again, they consume most energy. They're very common, and they do most of the work and displacement in HVAC. It's the largest and most important loads in heating, cooling, and refrigeration systems. Here's the most common symbol for motors. Again, it could look like that, like the circles, and also can look like those coils. So those coils here are actually, it's the internal winding of the motor. A motor consists of a rotor and a stator. The rotor actually rotate and do the circulation, and the stator is will actually stays in place. And we have the rotation between negative and positive. So if we look at this motor here, it says CFM, and if you look, it says condenser fan motor and evaporator fan motor. So when you look at the schematic, it should always say what is this symbol. And if you look at EFM and you don't understand what it means, but usually there's a legend in the side that says what is each component mean. Okay, so motors can be looking like that or like this one. What do you think this is here? This is probably a contactor. Actually, this compressor motor with an internal overload. This is an internal overload, and it's actually put in with the winding. So there's an internal overload inside this motor to prevent it from overheating. Solenoid. What are solenoids? Okay, I'm gonna need you to remember what solenoids are. Solenoids are motorized switches, meaning there's a coil, and when this coil is energized, it pulls up or down a pin. So in the morning when you turn on your car, before you turn on the ignition, if you put the car in the on switch, you're gonna hear a lot of solenoids opening and up. You're gonna hear a lot of ticking. The air pump will click and open the air inflow. You also hear the gas pump. You also hear a lot of clicks. So solenoids basically it open and close using magnetic field. So cause some action to an electric component, example relay or valve. So we'll work with some solenoids, and if you understand, a solenoid basically is a winding, and we said whenever you run current through a coil, what happens is two things. We said it heats up, and second, it will generate an magnetic field. So we have made a electrical magnet here, and this magnet will pull up and down the pin, and that pin can be used for many things. It can turn on and off a switch. It can turn on and off a valve. So a solenoid is a very, very useful tool that we use using magnetism to pull in and off a pin. Considered to be a load because, again, this is a coil, and this coil is consuming electricity. So it is a load. So a load is anything that is consuming electricity to do useful work, and sometimes it's just there to do something else, but could be not work, but it's still there and consuming energy. Okay. This here is a solenoid valve. So if probably you have this if you have hot water system. So there's a valve in here that water or any fluid can go through, and on the top here you have this huge solenoid with a coil inside, and this will push up and down into a valve to close or open a flow. So again, we can use the coil to open and close a flow for relay, or open and close flow for a valve. Okay, heaters, again, they look like resistances. They found in many systems in the wiring diagrams. They convert electrical energy to heat, in some cases electrical resistance. So again, going back to the basic concept, if you run current through any resistance, any wire, if you run current through any wire, you will do two things. One is magnets. You're going to create some kind of magnets. Second thing, you will create some heat. So heat can be used and magnetism can be used. So we can use that as a heater to heat the air with heat component, and also you might see this in a defrost cycle to heat to generate heat and heat the evaporator to get rid of the frost. And the other thing you might see is a coffee maker. The plate that heat the coffee pot is just basically a heater, which is a small little coil going through that heater made out of material that absorb electricity, and turns it into heat just by the property of the material itself. So hopefully when you do your project in your paper, you will run through some of these heaters and you can get oriented with how those heaters are put together. Again, this is what it looks like. It just looks like a resistance because it is a big resistance that heats when the current goes through it. Signal lights that are, so again, another thing, these are the beginning of LEDs. Those signal lights actually are put in the circuit to show you that that sub-circuit is on or off. You'll see these in a lot of controls. It's kind of, because again we said like it's really difficult to know if there's current or power going through that circuit. But if you have a light, the light is just meant for us to know that there's current going through that circuit at that time. So lights excuse me, that are illuminated to denote a certain condition of the system, and it shows that equipment is operating, is it on or off. Again, contactors and relays, we will spend a week talking about those, and they are open and close a set of contacts inside a circuit. And there are three components of any contactors and relays: coil, armature, and contacts. So what is the difference between a contactor and a relay? They are basically the same. The only difference is the size. A contactor is simply a large relay. Excuse me. When we say large, it means size based on amperage. So 25 amps or more, or 20 amps or more, it's called a relay or a contactor. If you use that term interchangeably, it's not going to be a problem. But they are the same. Contactor is bigger, bulkier, and it has more amperage. So 20 amps or more is a relay, is a contactor. These are contactors, and see it's a little bit bigger, and if you look at the amperage, it's a little bit different. But again, you can use the term interchangeably. The only difference is the amperage. And I had you, when you did the multimeter lab, to go and test a relay and see the contact and see if there's sound or not. And those things are really good to touch and get very close to and do testing for all those connections in it. So if you look at this contactor, there are current going through this line and this line, and it's disconnected from in the middle. So when you energize this terminal, there's one in the back over here, it will pull in those contacts, and these contacts are made. See, you can see also this in here. This is your coil. Once the coil is energized, it will pull in those two together, and those contacts will be made. So again, contacts, coil, and mechanical linkage. And symbols usually shown in the energized position. That is important to remember. Energized and de-energized. So let me draw a contact here. So this is a contact, this is a contact, and this is my coil. So when this is drawn like this, it means that's when there's no power. That's what energized mean. There's no power going through the coil. Once we turn on this switch, this coil will be energized, and this contact will be made, and they will be stuck together. So the contacts are when those two are stuck together, and energized means there's power going through the line, and if it's de-energized, it means what is the state when it's off. So off is de-energized, on is energized. More about contact. Normally, that's what it means when it's state when it's de-energized. Normally open, normally closed, and it's very important to understand these terminology a little bit as we go along. So a contact is what it looks like. Okay, so let's draw a contact here. This is when it's symbolically drawn, and this is the contact, and this is the coil. So let's say this is how it's drawn. That means this is a contact. This is double contact. There is two poles, and this is normally open, and this is normally closed when this is de-energized. Once this coil is energized, this will close, and this will close, and this will open. So it will switch. So, and again, you can have double pole, you can have three poles. The poles are the line of action of these contacts. And again, the book has a lot of information about contacts and relay, because we depend on those a lot for our controls and sub-circuits of HVAC systems. Symbols of normally open contacts, normally closed, and this is the coil. So the coil could be either circuit or just a coil. Magnetic starter. So a magnetic starter is a very glorified contact, which means it has more than 25 amps in it. However, it does have the ability to break when there is overload. So it's a contactor with an overload protection, and we will repeat that a lot because we will need to know how does it function and how does it reset. So what is overload protection? It's the ability to have a switch that will open and disengage the circuit whenever we draw more amperage than we are supposed to. Going back to the water analogy, let's say that your faucet is supposed to draw 1 gallon per hour. There was a leak somehow and the pipe burst, and now we're drawing 3 gallons per hour. If there's a overload protection, probably something will completely switch off the line, the water at some point. So to prevent a spillage, to prevent having too much flow, you want something to understand that when you have overload, if you're expecting to have 15 amps and suddenly you have 20 amps, this will break your system. Just likely when you have a pipe that bursts, you will have a lot of water in your house and you have flooding. So it's a way to protect your house or to protect your circuit. So flooding might not be as dangerous as electrical overload, because that could cause you to have fire and can ruin your equipment, and sometimes this equipment are multi-$1,000 equipment. Okay, switches. The main purpose of a switch is to close or open the circuit. They come in different types. Probably you've seen this in a house, and this one. This is a disconnect switch, which is a requirement to have for any equipment before you install it. If you look at AC outside or a boiler, you must have a disconnect switch for that equipment by itself. And some of them can be open and closed by temperature, or pressure, humidity, or flow, or manually. So switches open and close a circuit can be conditional or could be just manual operation. And these are toggle switches, meaning that they can go back and forth. Disconnect switches, they open and close the main power source for the equipment. So that's what when we say disconnect switch. It's not the regular switch, the on and off switch. It's the disconnect switch to cut the power from the entire equipment. Push button switches, they can go back and forth, and they can do more than one function. Some of them you can hold, you can press and hold. Some of them you can press and toggle. Thermostat, they are mechanically operated, and sometimes now they are electronically operated switches that is controlling the system based on temperature. Pressure switches, also they can be mechanical and they can be electronically controlled to shut off the system when there's high pressure or low pressure. Probably you'll see these in a lot of heat pumps, especially in the internal circuit, to protect the compressor from overloading. More pictures about relays and switches, and also normally open, push buttons, and engaging and disengaging. thermostat. So looking at the thermostat, what makes this one a cooling thermostat and this one a heating thermostat? If you think about it, the way that makes it easier for me to remember is if I look at this coil. This is supposed to be a coil. What happens to things when they're heated? They expand, right? So when this coil gets heated, it will expand and make the circuit, which means this circuit is for an AC, and this will cool the temperature and bring down the coil. So this is a cooling thermostat made up to make up the circuit once it's complete. And this one is a heating thermostat to open the temperature for the same thing. Because when this is cold, it will shrink and it will make the circuit, and the whole thing will be for heating, which means like either furnace or furnace. Okay, so these are the parts for the switches and poles, and again heating thermostat and cooling thermostat. Okay, moving on. Again, pressure switches, they do the same thing as thermostat, but they are controlled by pressure. Some of them are mechanical, like this one over here, and some of them are based on sensors. So again, logically speaking, if you look at this one will close on rise in pressure. So look at the push. So this will push and make the circuit, and this one, if it gets pushed, it will open the circuit. So it will open on rise on pressure. So those symbols that seem to be made to be a little bit like logical. So try to follow logic in that. If it's not, probably using a different symbol, you can look at the legend and find what those make. Safety devices, again, as we talked, we want something that will protect the circuit from overload. So fuses, they burn and melt when we have overload. There's also a thermal protection, like bimetal element, that will snap out, and that could be reused over and over again. Fuses has to be replaced, and also we have magnetic overload that it will disengage the circuit. So there are three types: either thermal overload, magnetic overload, or a fuse. A fuse will completely burn, meanwhile the other things will be reset. But again, they are to protect your devices and motors from overheating. These are pictures of fuses. Some of them you can replace the filament inside, and some of them you have to completely replace. Transformers. What do transformers do? Again, they change power and voltage from lower to higher, higher to lower, and this is the sample for transformer. What is your primary? Whatever you put in is primary, whatever you get out is secondary. And again, some of them are reversible, some of them are not. For example, the transformer ignition that we have, it will transform 120 volts into 10,000 volts. It's not reversible though. If you put 10,000 volts, I'm not sure you're going to get 120. So some of them are designed to be reversible, some of them are not. Follow the primary and secondary. If you put the primary into secondary, you will burn that transformer. So make sure you install correctly. You will use a lot of these because you will need to step down the electricity from 120 to 24 volts to use the control, which is usually low voltage. What is the reason for that? The reason is like we don't want to have high voltage for control because it consumes a lot of energy and it will make the equipment die faster. And also, you don't want the thermostat to be 120 where you will have that control and switch in your living room. It's easier and better to have the control as low voltage, so in case if there's a short, you will not injure somebody and have that in the living space. So again, for safety, you want low voltage to be the control and high voltage outside and far away where you do the work. Schematic diagrams. There are many types of schematics, and we'll do a whole chapter about schematic next week. So there's a lot of them, very common. They tell you how the equipment is installed, what are the components, what are the wires, which terminals connect to what other components, what are the options. And the more you look at them, the more you look at the legend, the more you'll understand how they are made, and you will start to develop familiarity with these schematics. Let's look at some of them here. So a pictorial diagram is known also as the label or line diagram, intended to show actual internal wiring, shows all the control panels components as a blueprint, so they have everything in it. And the components not shown in the electrical panels are shown outside the panels on the label. And factual diagram consists of the pictorial diagram along with the schematic diagram. So it has too much information it looks like. I think I'll have a picture later about that. So these have more components and more wiring inside, and it's really helpful when you are trying to do troubleshooting. However, it can be a little bit overwhelming and confusing to look at these when you're trying to do an installation, and that's why you use an installation diagram. They help you wire the unit properly because they show you specifically which terminals goes where, wire size, color coded, and also breaker and fuse size. They do not provide details about the equipment operation. So you see the equipment as a box and wire coming out and wires coming in, and that's it. And probably inside you don't see anything. You just see a black box, and it's a little bit helpful and not as overwhelming as pictorial or factual diagrams. So this is not an installation diagram because you see all the internal components, and you can see the legend here and what are those components. And again, even though there are some components, they're not very intricate. You see what they look like and how they're connected, but there are more wiring involved when it comes to these components. Again, some symbols from the same schematics. If you look at this one, this is a factual diagram, and as you can see, there's so many wires in here, even though this is its own control and this is its own control, and here you have more control, but you see that there's so much wiring than you need to know, and this could be a little bit confusing. But if you look at it slowly, I mean one chunk at a time, and look at the terminals and try to match that with the control you have in hand or what you're looking at, it will make things a little bit easier. If you look here, you'll see the colors for the wire, and here you also see the colors for the thermostat, and you look at these switches, pressure switch, and these again connected in series because they are safety switches, and this dashed line means that this is a control box by itself, and this in here is a motor because you see the two winding in it. So again, looking again at this legend, it will tell you what each component is and where is it located. But again, you see a lot of information here, it can be a little bit overwhelming. So far, these are the key terms that I want you to remember. Contactor, which is a relay with more than 20 amps. De-energize, the state of the equipment when it's off. Disconnect switch. Energized, on. Factual diagram, a lot of information. Fuse is protection. Heater is resistance that makes heat. Installation diagram, very simple diagram that help you know where to connect the wires. Loads, anything that consumes electricity. Magnetic overload is a contactor with overload protection. Magnetic starter is again a contactor with a magnetic overload. A motor is something we use a lot in HVAC, and it does the rotation. Normally means the state when it's de-energized. Normally closed, normally open. Pictorial, again a lot of information, don't worry about that. Pole is the line of action of a relay. Pressure switch, push button switch, relay, schematics. Schematic is a very general term, could be pictorial, could be ladder, could be installation. Signal lights to show, it's a light that show you that that circuit is engaged. Solenoid is a very useful device that can open or close using mechanical linkage and a pin. That's a solenoid. Could activate a switch, electrical switch, or it could activate a fluid valve. Alright, that sums up the information we have for chapter 5. Please go over the book and let me know if you have any questions. Thank you.